Hey everyone, um, we are US West 1A. Let me introduce our team members. Arijit Mandal, Hulbert Jong, Manali Jain, Rudy Wachudi, and Farun Jindal. So let's take a look at our architecture diagram. So let me start here from the bottom. We have our database layer. We are using MongoDB to store all our data, and we have implemented Mongo sharding. And since our application uses 5 microservices, so we also have 5 Mongo sharding clusters, and each of these cluster will responsible for one service, and we cannot show the other two because of a space limitation on the diagram. So as you can see here on each of these Mongo sharding clusters, we have one config server, and then two shard clusters, and one uh, Mongo query router. And in the config server, we have 3 Mongo replicas, and one acting as the primary, and the other two as the secondaries. And on the shard clusters, in each of these, we'll also have the same setup. So there are 3 Mongo replicas. One will be the primary, and the other two will be the secondaries. And then we also have this Mongo query router. This will be the Mongo instance that will be interfacing with our Golang API microservice. And then on the business layer, uh, our application have 5 microservices: uh, user, restaurant, menu, order, and payments. And we deployed 3 of our services: user, restaurant, and menu, on Amazon AWS ECS. And we actually deployed them on a separate ECS. We just don't have the space for it, so we kind of group them together in this diagram. And so in each of these ECS cluster, we have 3 instances, and they're all connected to load balancers. And as our project wow factor, we also deployed our order service to Microsoft Azure Kubernetes service. We set the desired port at 3, and they're all also connected to load balancers. And additionally, we also deployed our payments service to Google Kubernetes Engine, and we also set the desired port to 3, and they're also connected to load balancers. And running in front of our Golang API microservices, we have the API gateway layer. We are using Kong API gateway, and we have deployed this Kong API on AWS EC2. And then finally, on the application layer, we have implemented a client app that is built using React.js, and it is running on Heroku. And let's move on to our demo. And from here, Farun will take over. Thank you.
Look at our UI. So this is our counter burger application. So in the homepage, you enter the zip code, and if you click on go, you'll be shown all the restaurants that there are in that area. And if you want to go to a restaurant, just click on order, and the menu will be displayed. You can add any item you want, like 1, 2, 3 items, and then you can click on cart, and you can see the items that you have just added. You can remove the items by clicking on cross, and then you can go and check out, but it won't let you check out because right now you're not signed in. So we already have a user, so we'll sign in right now, but if you are not signed in, you can sign up and then sign in. So now that we are signed in, we are able to see our cart. We go to cart, we see our uh, items, then we click on checkout, and we enter the address details and the payment details, and then we can place the order. Once we click on pay for your order, the order is placed, and you can see the summary. If you click on your username, the order is displayed, and you can see what amount it was. So moving on ahead, we'll show how we scaled our this burger counter application on the AKF's cube. So along the x-axis, we made multiple replicas of our application. So we have 3 nodes for each of our application, and this also makes ensures us that if there's a any failure on a single node, the other two nodes can take care. So let's see if it's actually working. So we'll use the menu Kong API endpoint to hit the server, and we'll get the IP of the server. So each time we hit the API, we are getting the different IP. That means we are actually hitting a different node each time for the same service. So moving on ahead, we have also scaled our application along the y-axis, which will be later explained by Manali. I'll move on to z-axis. We have scaled our application on z-axis using sharding. So we'll show you how we did sharding. So this is our Mongo's query router. So let's see how many shards we have. So right now we have two shards, shard 1 and shard 2. And let's see what is the shard distribution among those shards. So as you can see, we have six docs in total, and two docs reside in shard 1 and four shards reside in shard 2. So let's see if the count is right. Let's go to shard 1. Okay, so as you can see in shard 1, the count is 2 in each node. Okay, moving on to the shard 2. Okay, as you can see in chart 2, we have the count 4 as we saw in the chart distribution and in each node. Okay, now let's try to add some data and see if the sharding is being performed and see in which shard it goes to. So data has been added. So let's see which shard it went to. Let's go to our query router and see the doc count. So as we can see, the doc was added in shard 1. The count has changed from count 2 to count 3. Let's go to the shard 1. As you can see, the count has changed from 2 to 3. Let's see in the replication nodes, the count is 3, and similarly for node 3. Okay, so the count is good to go. Let's now try to partition this shard 1 and see if our application is network tolerant, partition tolerant. So we'll be stopping all the traffic uh, from the node using the IP tables. Now that we have put an entry to IP tables, it cannot connect to primary node and the secondary node. So let's try to delete the data and see what happens. So we are going to delete the data that we just added. Okay, the data has been deleted. Let's look at shard 1 primary. The count should be changed from 3 to 2, and similarly for the node 2 which is running. Let's see what happens in the node that is down. So it's showing the count as 2 because the data has not been deleted, because it's a stale data, because it's not able to communicate with the primary nodes. Now let's open the traffic and see if the data is replicated and data becomes in sync. Okay, Mongo is fairly fast on this stuff. The data should be replicated, and as you can see, the data has been updated from 3 to 2. So this is how we scale along z-axis using the sharding. Now y-axis scaling will be explained by Manali.
Now we are going to demonstrate the y-axis for our application, that is the microservice split. As Rudy already mentioned, that we have 5 microservices in our application. So with this, we are demonstrating that if one service is taken down, the other services are not affected by it, and our application works fine with it. So let's go for the demonstration of this. Here we are doing is we are taking the payment service down. So this is Google Kubernetes engine. We are getting the pods here first. So we'll see that there are 3 pods running. They are up and fine. So this is the payment microservice. You can see here. Now we are taking down the pods by having replicas set to 0. And if we do kubectl get pods again, we'll see that the pods are terminating. Now, as now we have our payments application services down, we go to our UI and enter the zip code. We see a list of restaurants. We order some of the items from the menu, and then we add to the cart. So adding cart is working fine. Restaurants is working fine. Now we go to the cart. We check out for doing the payment, and we'll see that the user is logged in. So we enter our details. So after entering the details, what we are going to do is to proceed for the payment. Now we click on payments and proceed for it. But as our payment applications microservice is down, we won't be able to process for the payments, and we'll get an error soon. This may take a time because of the browser timeout error. So when the browser timeout is over, we'll get the payment service error. Now you can see that the browser timeout is over and you get a payment error. It says please try again. So if we go back to home, though the payment service is down, our other microservices are working fine. So if we go to cart, delete some item from here, let's say delete one of the item, we get 2 items in the cart and it works fine. So order is working fine even with the payment service down. So it shows that we have our microservice implemented correctly. Now we are making the payment service up again by setting the replicas to 3. And if we do kubectl get pods, we'll see the pods are running up and again. Now, if you go to our application, check it out again, fill the payment details and proceed for payments, it should work fine. So let's see. So when we go for pay for order, we see the payment summary and the payment is done successfully. So this demonstrates that even if our one API servers or the microservices down, the other microservices are not affected by it. And we can see all the orders that have been placed by the user by clicking on this. So we see that um, the microservice functionality for that, the y-axis is implemented correctly in our application. Next, we'll proceed on to summary, and this will be demonstrated by Fulbert.
Hi there. So just a quick recap of what we accomplished so far. So we replicated the counter burger application that's already exists. And here's how we did it. So from the bottom layer, from the database layer, we implement Mongo sharding. Basically, this is our, our solution for the scaling on the z-axis. And moving up to the business layer, we also deploy using our Golang API and deploy it in various cloud platforms. And moving up again, we have the Kong Gateway in the AWS EC2, and we deploy our app on the Heroku. And yeah, as a wow factor, we explore various cloud platforms. We started with Amazon's AWS ECS. It's pretty nice to use, and we can also use the application load balancers that can be configured in ECS. And another platform we choose to experiment with is the Azure Kubernetes service. It's pretty nice, but kind of lacking compared to the other one we tried, which is the Google Kubernetes engine. As of now, I believe Google Kubernetes engine is the best cloud platform we can get if we are looking for Kubernetes platform. And that's our recap so far, and we just to talk about the challenges and out learning takeaways that we have. So for the challenges, we tried to do another gateway, API gateway, which is the AWS API gateway. Uh, things we run into an issue that course is not being enabled if we return any other response besides 200. And basically, since cannot solve that issue in on time, we move to the Kong API gateway. And we also have issue with running on AWS ECS because the manual is not complete. We run some issue on our containers failing the health checks. But after we fix that issue, everything is running normal. For the takeaways, we learned how to deploy our apps in various cloud technologies. We use cloud technologies from 3 different providers, and it's scalable and it's partition tolerance. And thank you for listening to our presentation.